Semua sudah dinner ke? Okay, the recording is now started. So again, a very good evening and welcome to everyone. 5 Arcade, 5 Baiduri, 5 Sitting. So this is our lesson for 3.3, electromotive force and internal resistance. So there are two things we will learn in this content standard. What is electromotive force and what is meant by internal resistance of a tri-cell or batteries. Okay, so you can refer to your module. There are 4 learning standards altogether. So for tonight, we are trying to discuss the first, second, and third, and a few example of question related to the 4th learning standard. All right. Okay. So the first one, to define electromotive force. Anyone knows what electromotive force means? Any idea? Maybe some of you who went for tuition or you do your own reading. Can you share anything you know about electromotive force?
Battery.
Batteries.
Ah,
Okay. Anything else? Others? What do you think? What is electromotive force? Welcome, Junjuan, and for those who just joined us. So let us take a look at this stimulus. Okay, students. So this is a torchlight. I believe everyone has used a torchlight before. Semua orang pernah guna lampu suluh torchlight. Okay, it shows a simple torch and its circuit consisting of a cell. Okay, so a torchlight consists of a battery. Okay, so you put the dry cell in, and this is the bulb at the front. Okay, so this is the switch. Okay, mean the handle. If you pull on the handle, mean the switch is closed. So current flow to the circuit, so the bulb of the torch will be light up. Okay, and you pull it to off, mean you open the switch. So when you open the switch, mean the circuit is broken, so no current flow, so the bulb does not light up. Okay, this is how a torchlight function. Okay, the statement here, when the switch is closed, okay, as I mentioned, the circuit is complete, the bulb light up, showing a current flow in the circuit. We understand before what is a current, student. What is the definition for current? We learned this in 3.1. When you close the switch, we understand current flows through the circuit, so the bulb light up. So I would like to make a throwback. So what is meant by current? Anyone remember? Baru belajar saja 3.1, 3.1. Current and potential difference. So what is meant by current? Okay, current means rate of flow of charge. Okay, remember current means rate of flow of charge. Yes, rate of flow. So we understand that when current flow mean there is a charge flow in the circuit. Okay, current is the rate of flow of charge. So the flow of current refer to the flow of charge in a circuit. So the question here, the big why, is what causes the charge to flow in the electric circuit? How charge can flow in an electrical circuit? So this is what we are going to answer in this lesson. Okay. So this is a few animation, short animation so you can understand what is meant by electromotive force. Okay, students, any idea you can get from this short simulation, either the top or the bottom one? Look at the bottom one. This is a battery. Okay, Nicholas, just now you mentioned about battery. Okay, this is a battery. So it's written there, energy change of charges in a battery as a source of EMF. Okay, so what is this people represent? What is this people represent? Okay, these people, battery supply forward force for charged particle to move forward. Sinwe say electromotive force. Okay, if you look at this bottom simulation, students, the people here is representing the charge. Okay, representing the charge. Okay, what happened when they enter the charge? You can see this one, it represents all men. Yeah, so you can the analogy is as a weak charge. Okay, weak charges, and after they pass through a battery, what happened? They will be charged. Okay, they receive an energy, and when they come out from the battery, see what happened? They become young again. The old man turn into a young man. The old lady turn into a young woman. So means this battery is used as a sources of energy so that the charges can move throughout the circuit. Macam you nak berjalan jauh, you kena makan dulu, right? You nak berlari marathon, you want to participate in Penang Bridge, International Penang Bridge Run. So you have to gain some energy first to go through a very long journey. So this is what done by the battery. They are called as the sources of EMF. So what is an EMF? The first one, battery is a sources of electrical energy, okay, which move the charges around the circuit. So what kind of energy the battery give to a charge? The answer is electrical energy. A battery give electrical energy to the charge. Okay, so you know battery, students. What do we have inside a battery that enable it to pass through current flow through them? Inside every battery we have electrolyte, right? Okay, you learn in chemistry, electrolyte. So battery convert chemical energy to electrical energy, okay, by the help of an electrolyte. Every single battery, every brand of battery, they have different kind of electrolyte. That's why every brand of battery have sometimes have a different value of EMF or internal resistance. Later we will take a look at that. Okay, then what happened? Okay, what happened to this energy? This energy, okay, the chemical energy convert into electrical energy, so it will use to move 1 coulomb of charge in the circuit. Okay, so we have a battery, it convert chemical into electrical energy. And later, what will this electrical energy do? It will give energy to each 1 coulomb of charges pass through the battery. Okay, so which means each 1 coulomb of charge, so each of this person represented 1 coulomb of charge. Okay, each 1 coulomb of charge that flow through the battery will receive electric potential energy to move in the circuit. Okay, so work is done by the battery. We say that the battery is doing work in supplying energy to the charges. And this work done is what we call as an EMF. Okay, so from here we derive what is EMF, electromotive force. It is referred to the work done by the battery in moving 1 coulomb of charge across a complete circuit. Okay, boleh follow tak daripada point number 1 until point number 5? How the battery supply energy to a charge. That is what we call as an EMF, electromotive force. Okay, ini example of charges flow. Okay, so they pass through the battery, they will be charged. Dia akan terima energy so they can move around a complete circuit. Okay, so once they move around a complete circuit, we say that current is flowing through the conductor. Again, what current is? A rate of flow of charge. Okay, student, this one I think not included in your module, right? You can add this later as an additional point. How to understand where is this EMF coming from? Okay, next. So by here you can write the definition for electromotive force in your module. It is defined as total work done. Okay, total work done by a source. Source means here battery. Okay, in driving 1 coulomb of charge around a complete circuit. Or you can write it in this way. EMF refers to total energy supply. Total energy supplies similar to total work done. The unit is in joule. Okay, to drive 1 coulomb of charge around a complete circuit. You can write any one of this definition for EMF. Okay. And this is the equation for EMF. Students, this is the symbol for EMF, epsilon. Okay, the name is epsilon. I think you are using the symbol also in at maths. Okay, and E ini energy supply or work done by the battery. Q is the total charge flow. So this is the formula for EMF. Okay, EMF is energy supply or work done in moving 1 coulomb of charge across a complete circuit. And the unit for EMF is volt or joule per coulomb. Energy is in joule, charge is in coulomb, so joule per coulomb, also known as volt V. Okay? So did you get the first idea of electromotive force now, students? Boleh? Okay, any questions so far? Ada apa nak tanya tak? 5 Akid, 5 Baiduri, 5 Cicin. So far we have 23 students here. Thank you for your commitment. I really appreciate it. Okay, so can we go through the next slide? Are you done with the definition for electromotive force, students?
Yes.
Okay. Wisin, are you doing good there? Eliana, Goja? Okay, Okay, next. Okay, this is the first activity for you to understand more on EMF. Okay, it is to compare between EMF and potential difference. Student, before this we have learned potential difference. Okay, can you share what do you understand by potential difference? We've learned potential difference in 3.1 together with current. What is potential difference?
Teacher, I have a question.
Yeah, Sinwei.
C means that is a column.
Sorry?
1C is
Yeah,
equals
1 coulomb. 1C is 1 coulomb. Okay?
you.
Okay. Capital C, huruf besar C tu must be in capital. Okay, anyone remember what potential difference means? Potential difference. Later we can compare what is the difference between EMF and potential difference.
Energy required to transfer a unit of charge across a component.
Across a component, okay, or in between 2 points in a circuit, and the 2 point across component, across a conductor, okay, or across a resistor. Yes, that is potential difference. Energy required to move 1 coulomb of charge in between 2 points or across a component in an electrical circuit. The component here, the 2 point is in between bulb, for example, in between resistor, in between hair dryer, if you put hair dryer there, in between rice cooker, okay, electrical component. And EMF is the energy done, okay, energy supply or the work done in order to move 1 coulomb of charge throughout a complete circuit. Itu beza dia. Potential different only at certain point, but EMF it cover. Okay, it cover and it supply energy so the charges can move around 1 complete circuit. So you can say EMF is bigger somehow than potential difference. Okay, back to this activity. We want to compare between EMF and potential difference. So this is the circuit related to this activity. We have our circuit there involving a dry cell. This is our voltmeter. This is our bulb, emitter, and switch. Now the switch is in open position. Open position means the circuit is incomplete. So no current flows in the circuit. So at this position, you can observe what happened to the bulb. So definitely the bulb won't be light up, right? Because no current flow in the circuit. So you can record the emitter reading and the voltmeter reading when the switch is open. Then second step, now we close switch S. When we close switch S mean now the circuit is complete. So there is a current flow in the circuit. So now you will see a reading on both emitter and voltmeter. Okay, so what will be the findings for this experiment? Okay, so this is the diagram for the open circuit showing a reading on the emitter and reading on the voltmeter. And on the right side is the diagram for emitter when the circuit is closed. Down there is the reading of the voltmeter when the circuit is closed. Okay, can you see the reading shows there? when the circuit is open, okay, open means no current flow, so you can see the ammeter reading read 0, no current flow. Okay, how about the voltmeter reading? Can you see the reading there, student? What is the reading shows that? Boleh nampak tak? Can you see? 0, 1, 2, 3. It point at 3 volt, right? When the circuit is open, the voltmeter shows reading at 3 volt. Okay, now we close the circuit. Close the circuit means there is a current flow. You can see the current flow in the circuit now is 1 ampere. Kita tengok yang bawah lah sebab we connect our wire to this. Okay, 5 ampere. So we take the lower reading. 5 ampere. Ini kenapa dua-dua 5 ampere? It's supposed to be this one. Okay, so we take the lower reading. Okay, then this one for the voltmeter. Okay, voltmeter, it shows a reading now less than 3. Okay, less than 3 volt. Okay, so this is the example, this is the example of result for this study. Okay, state of the bulb when the switch is open. So you can write the bulb is light off. Okay, meanwhile, the reading of the ammeter is 0 ampere. Voltmeter reading 3 volt. Okay, this is the condition when switch S is open for state of bulb, ammeter reading and voltmeter reading. And this is the condition supposed to be this one. Label dia salah ni sebab actually this label ini 1 ampere. Sorry, it's now. Okay, this one 1 ampere, this one 5 ampere. So now we connect the wire to a 1 ampere. So we read the top scale. If you connect this to this one, so I connect this first so later you don't get confused. This one supposed to be 1 ampere. Okay, as shown here. So we have two terminal, okay, because we have two scale here. The top scale read until 1 ampere, the lower scale read until 5 ampere. Similar to this side. The top scale read until 1 ampere maximum, means when we connect the positive terminal of the wire here. So the lower scale maximum current it can read is 5 ampere. When we connect the positive terminal of the wire to this, there is ini yang silap di sini Okay, tolong betulkan. So now back to the reading on the voltmeter, student. It now shows here 2.7. Okay, so I hope you can see the reading. Every small scale here 0.2. So here is 2, 2.2, 2.4, 2.6, 2.8. So the needle is between 2.6 and 2.8. So our reading is 2.7 volt. Okay. So the conclusion or the question, what is the EMF of the battery showing from this table, student? Can you tell me which one shows the EMF of the battery? Is it 3 volt or 2.7 volt? What is the EMF of the which one?
I think it's 3.
It's supposed to be 3 volt. Yes, very good. So the reading of the EMF battery is 3 volt. Okay. How about the second question? What is the potential difference across the bulb when switch S is closed? So it should be 2.7. So this is the difference between EMF and potential difference. EMF is the voltmeter read, okay, the potential difference in the battery, EMF, 3 volt. Meanwhile, for the potential difference, it reads the potential difference across the conductor, across the bulb, across the electrical component. Okay, then what's next? Okay, discussion. We have 3 questions to deal with them. Number 1, what is the change in energy when the bulb lights up? Okay, can you tell me the energy changes occur here, student, when we switch on the bulb? When you close the switch, what kind of energy change to what type of energy?
This need to calculate or not?
Yeah, come again.
Calculate or no need?
Come again, cannot hear.
I mean that need to calculate or not?
Bukan, energy change saja. What energy convert to what energy? This is the beginning of this question. What is the change in energy? Okay, so you can say electrical energy convert to light energy and heat energy. Okay, electrical energy convert to light energy and heat energy. Okay, light when the bulb light up, and also it produce heat there from the filament. Okay, question number 2, students. What is the quantity of electrical energy released by the bulb for 1 coulomb of charge that flows through it? Okay, how to do this? What is the quantity of electrical energy released by the bulb for 1 coulomb of charge that flows through it? Any idea? Quantity of electrical energy released by the bulb for 1 coulomb of charge that flows through it. And the third question, what is the quantity of electrical energy that is required for 1 coulomb of charge flowing through the dry cell? Okay, so question number 2, the tips is you can relate to the definition for potential difference. Okay, and question number 3, you can relate to the definition of EMF. Sebenarnya tak perlu kira pun, you tengok from the reading. Okay, this is the reading we get when the circuit is closed, and this is the reading we get when the circuit is open. Okay, this shows EMF. Okay, and this shows potential difference across the bulb. So what is the answer for number 2, student? What is the quantity of electrical energy released by the bulb for 1 coulomb of charge flows through it?
2.7 volts.
Yeah, the answer is 2.7. Remember what potential difference means? Energy required. Okay, energy required in order to move 1 coulomb of charge across a conductor. So the answer is 2.7 joule. Okay, 2.7 joule. Okay, remember voltage is joule per coulomb. So to move every 1 coulomb of charge, it requires 2.7 joule of energy to do so. Okay, number 3, what is the quantity of electrical energy required to 1 coulomb of charge flowing through the dry cell? So we're back to EMF. So the answer is
3 joule.
3 joule. So 3 joule. 3 joule or 3 joule energy. Kita tanya energy, right? So 3 joule. So are you clear with this? Question number 2, question number 3. Question number 2 related to potential difference across the bulb, and question number 3 refer to the EMF of the dry cell. Okay, so from here we can write a comparison between EMF and potential difference. Okay, what is EMF? The voltmeter reading when the switch is open. Okay, so you can write voltmeter reading, okay, when the switch is open. Okay, meanwhile for potential difference refers to voltmeter reading according to this activity. Okay, in a closed circuit, or voltmeter reading when the switch is closed. Okay, that is the first comparison. Okay, second, EMF is used in reference to source of electrical energy. EMF ini source of electrical energy supplied by battery. Okay. Meanwhile, potential difference is refer to the electrical component in a circuit. Okay, used in reference to electrical component in a circuit, such as motor or light bulb, or any electrical devices as I mentioned just now. Okay, and the third comparison you can write EMF is the electrical energy. Okay, electrical energy given to or supplied to 1 coulomb of charge flowing in a complete circuit. All right. Meanwhile, for potential difference, it refers to electrical energy transformed to another form of energy when 1 coulomb of charge pass through a component in a closed circuit. The fourth comparison, they are similar in SI unit. Unit SI dia sama, both are measured in volt. Okay, volt. Joule per coulomb or volt. Okay. So anything you would like to ask on this comparison between EMF and potential difference? Are you doing good so far with EMF and potential difference? Can see the difference? Boleh nampak tak beza dia?
Yes.
Okay. So are you done with this comparison, students? Okay, I give you 1 minute if you want to copy down the comparison between EMF and potential difference. While if anyone have a question, you can ask now. Boleh tanya sekarang while we are giving time for your friends to settle this table. Welcome, Hong Jin. Okay, so far we have Goja with us, Wei Shen, Cheryl, Zhang Yang, Eliana, Eric, Lai, Go Jun Heng, Yu Qing, Chun Chuan, Hui Xin, Jia Yi, Kisian, Zilip, Ang Zisuan, Nicholas, Ke Yi, Hong Jin, Jin Pei, Xin Wei, Yuan Han, and Wong Wei Jing. Okay. Wei Jing, do you have anything to ask? Yuan Han? Haha. Okay. Can we move to the next slide, students? Boleh bagi slide yang seterusnya? Okay. So, okay. And then, okay, students. Okay, now let's take this. This is an example of dry cell, brand Duracell. Pernah beli tak bateri jenis ini? Duracell. What kind of battery you always use at home? Ever ready? Every day? What kind of battery you are prefer to use? Can share? Energizer? Or rechargeable
Lead
battery?
sulfuric.
Yeah? The brand of the battery, Nicholas. Selalu you beli bateri apa? Okay, students. So you are given this diagram of a battery. This is AA, okay, double A battery. So we have triple A, double A, and okay. So what does the label of 1V, 1.5? Can you please make a correction here? In your module, it's stated 2.5 volt, right? So you change. What does the label 1.5 volt on a battery means? You can see here it label 1.5 volt. So what does it mean by this label, students? So this label actually represent the EMF of the dry cell. Okay, the EMF of the dry cell. It shows that the EMF of this dry cell is 1.5 volt. Okay, so the voltage level on a battery or cell indicates its EMF. Where here 1.5 volt mean 1 joule of energy is required to move 1 coulomb of charge around a complete circuit. Okay. So you understand now what 1.5 volt mean. 1 joule of energy is required to move 1 coulomb of charge around a complete circuit. Okay. So you know kalau dia tulis 3 volt, 4.5 volt, so we understand if written there 4.5 volt mean 4.5 joule of energy required to move 1 coulomb of charge around a complete circuit. Okay, then next. Okay. So that is to do with the first learning standard to define what is meant by EMF, electromotive force. Yeah, it's my daughter, the youngest one, Wei Shen. Okay. So before we go to the second learning standard, can someone again give me the definition for EMF? What is EMF, students?
Total work done by a source in driving 1 coulomb of charge around a complete circuit.
Okay, very good, Sinwei. Okay, how about the rest? Ada lagi nak cuba? Yuan Han, what is EMF? Hong Jing, what is EMF? Total work done or total energy required in order to move 1 coulomb of charge around a complete circuit. Very easy. Okay, now let us move to our second learning standard. Explain internal resistance. So then before this, we learned resistance. What is resistance? You learn in 3.2, students. In 3.2, we learn resistance is the ratio between voltage and current. Okay, between voltage supply across a conductor and the current flows through it. But here we are dealing with internal resistance. Internal resistance means the resistance inside the battery or the dry cell. Okay, so this is activity 2, the second activity, to study the effect of internal resistance on voltage drop. So there are two terms there. The first one is internal resistance. The second terms we have voltage drop. So what is internal resistance? What is voltage drop? We are going to look to discover at this second activity. So this is the circuit provided related to this activity. So we set up the apparatus using a Duracell, right? So this is the brand. So we place a Duracell dry cell here connected to the circuit, ammeter, voltmeter there, and this is the bulb. Now the switch is in open position. Okay, we record the voltmeter reading as the EM. So you understand that when the circuit is now open, the voltmeter will read EMF of the dry cell. So let's say the EMF of this dry cell is 1.5 volt. So what voltmeter here will read 1.5 volt. What is the ammeter reading here, student, now in this position of switch? It reads? Any reading shown by the ammeter now?
Where?
Ammeter. Now the switch is open. The voltmeter reads 1.5, the EMF of the cell. How about the ammeter? Any reading shows there now?
No.
No, okay, it reads now 0 ampere because no current flow in the circuit now. And then number 4, you can calculate the difference in voltmeter reading before and after the switch is closed. Okay, now you close the switch. Okay, so you can see there will be changes in the voltmeter reading, and now there is a reading on the ammeter. So we repeat this activity by replacing the Duracell with Energizer, another brand, Energizer dry cell. Okay, so this is the example of result. Okay, ini example saja ya, contoh result yang you akan dapat untuk eksperimen ini. Okay, I show you the reading first. Okay, so when you are using Duracell, okay, both battery have 1.5 volt the EMF. Okay, but the moment we close the switch, you can see that this is the reading on the voltmeter for Duracell, 1.5 volt, and this is the reading for Energizer, 1.3 volt. The reading is less. Okay, so from here, it shows a voltage drop, mean the difference between the EMF and the voltmeter reading when the switch is closed. We call it as a voltage drop. So 0.1 for Duracell and 0.2 for Energizer. Okay, students, the question here, why should new dry cell be used in this activity? Okay, every time you change with another brand, the battery must be a new one, not already used one. Okay, why? Because we want to make sure the EMF in the battery is at 1.5 volt. Okay, and because this EMF, it will be reduced the longer you use the battery, so the lower the EMF will become. Sampailah bateri tu you guna sudah torchlight sudah tak menyala, then you have to throw the battery, change with the new one, because energy dia sudah habis, semua sudah bagi kepada charge flow through them, so they are drained out of energy. So that's why in this experiment, every time we change to a new brand, we must use a new battery. Okay, which brand of dry cell experience greater voltage drop? So from this table, which brand, student, experience greater voltage drop? So mestilah it must be the Energizer. Yes. Okay. Energizer. So Energizer has a higher voltage drop compared to Duracell. Okay, third question. Can you respond? What do you think causes this voltage drop in between these two battery? What do you think the reason why there is a voltage drop before the circuit is open and closed?
I think is heat energy released.
Heat energy released. Okay, any other answer? What do you think causes the voltage drop between these two dry cell? Cindre said there is heat produced. Okay, any other reason you can think? Okay, any idea? Internal resistance different. Yes, very good. Okay, because yes, the answer is actually due to the existence of internal resistance in the battery. And we are using different brand. As I mentioned earlier, different brand produce from different, they are sometimes using different kind of electrolyte, the chemical inside. So different electrolyte give different internal resistance in the battery. So it will give different voltage drop. So the answer is internal resistance are different due to different type of electrolyte. So from this voltage drop, we understand that the higher the internal resistance, the higher the voltage drop. So from this table, we understand energizer has a higher internal resistance that causes to this higher potential drop. So kalau you nak guna battery, which one you prefer? Which one you must buy? If according to this result, Duracell or Energizer, which one better?
Duracell.
So Duracell, okay, with Duracell because it has lower internal resistance, so it causes lower voltage drop when you are using it. Okay, next. Okay, so this will bring us to a definition of internal resistance, students. So internal resistance is actually caused by the electrolyte. Okay, I repeat, internal resistance in a battery is caused by its electrolyte. Okay, this is the definition for internal resistance. Internal resistance refers to the resistance caused by electrolyte in the dry cell. Okay, and the unit for internal resistance similar to a unit for resistance, only the symbol is small r. Okay, the symbol is small r, the unit is in ohm. Okay, so big R is resistance in a wire, small r is internal resistance in a battery. Okay, I repeat, big R is resistance in a wire or in a conductor or in any electrical component, while small r goes for internal resistance inside a dry cell. Okay, so what will this internal resistance cause? Okay, number one, there will cause loss of energy, mean production of heat. Okay, in the dry cell, as work should be done to move 1 coulomb of charge against the resistance inside the dry cell. Okay, second, this internal resistance will also cause potential difference across the dry cell terminal to be less than the EMF when the current flows in a complete circuit. Okay. So this is the effect of the existence of internal resistance in a battery. So every battery has internal resistance due to their electrolyte. Only some is higher and some are lower. Okay. And this is the formula how to find a voltage drop. Kalau you tengok formula ini IR, okay, equal to EMF minus the potential difference.
Teacher.
Yes.
Who
is it? Zinwei, yes.
Is the higher the internal resistance that seems like more heat energy is released.
As written here, yes. This one, loss of energy because a product, it generate heat. Okay, due to high resistance.
If for the previous question, if I answer the question like I just write more heat energy is released at mark about.
Which one? The voltage drop?
The question 3, the previous question.
The previous one, the voltage drop, is it? Which one give a higher voltage? This one.
Yes.
Why there is a difference in voltage drop?
Yes, if I just write more heat energy is released at the set point.
Actually, the heat energy comes out from the internal resistance. So actually, the main answer you must write. You must mention this somehow you must mention about the internal resistance. Okay.
Oh, because the internal resistance is the key point.
Yeah, the key point is internal resistance. Okay. Then yes, it will produce heat. Okay.
Okay, thank you.
Okay, very good. Okay, students. Okay, next. Okay, so this is how we derive a formula showing internal resistance, EMF, and voltage drop in a battery. Okay, so you can write this formula. So this is the EMF, work done in driving 1 coulomb of charge around a complete circuit. EMF equal to potential difference. Work done in driving 1 coulomb of charge in the external circuit. Okay, this is represent potential difference plus, okay, plus the work done in driving 1 coulomb of charge in the internal circuit. Okay, this one refer to the voltage drop due to internal resistance. So here the formula is E equal V plus I R. Okay, this is the formula relating EMF, potential difference, and voltage drop. Okay, so you can rearrange this formula making IR as a subject. Kalau you tulis semula, dia boleh jadi seperti ini. IR equal to EMF minus potential difference. Okay, as shown in the previous slide. Okay, so this is what I want you to understand. EMF equal to the potential difference plus voltage drop due to internal resistance in the dry cell. Okay, so are you done with this? Okay, nanti kita tengok soalan how to apply this equation. Okay. Okay, next student. So as I show you before, this is the equation you can write relates EMF, voltage, current, and internal resistance. Okay, this is what the references for each symbol. Okay, I for current, IR for voltage drop, R for internal resistance, V voltage, E for EMF. Okay. So this is the equation we generated from the previous slide. EMF equal to potential difference plus voltage drop. Okay, and when you rearrange this by using equation, this is the equation we learned before, Ohm's law, V equal IR. Okay, so write an equation related to E, V, I, R, and R. Okay, so V here can be written in terms of IR. Okay, you can replace V by IR. That's why here we write IR. So you can combine. Okay, I write back so you can see EMF equal to potential difference plus potential drop. Okay, IR, potential drop. So we write back EMF equal to V ini can be written in terms of IR, Ohm's law. Okay, this is again the potential difference, IR. So these two, it has same I, right? Similar. So you can bring I outside, then we can put a bracket there. R plus small r. Okay, so EMF equal to current in bracket resistance across conductor plus internal resistance of a dry cell. Okay, can you see this relationship? How we relate all these parameter through this equation. Okay, yes. Okay, next. Okay, you are done writing the two formulas, students? So from here, we can come up with another one, E equal to IR plus IR. Okay, next. Okay, that is to do with the second, to determine or to define what is internal resistance. So for tonight, we have learned EMF and internal resistance. So are you doing good with this too? Can you follow me up to this point?
Yes.
Boleh ikut cikgu Okay, cikgu harap yang lain pun boleh follow. Okay, now the third learning standard student. Conduct experiment to determine EMF and internal resistance. Okay, let us take a look at this example of experiment which can be conducted. How to determine EMF and internal resistance. So this is all the apparatus required. We need a dry cell to supply the EMF, a rheostat to adjust the current flow in the circuit, ammeter to read the current, voltmeter to read the voltage, and this is the resistor we are using 1 ohm or 5 ohm resistor. Switch and connecting wires all are connected as shown in this diagram. Okay, so we connect the circuit, turn on the switch, adjust the rheostat until the ammeter reading 0.2 ampere. Okay, then you record the voltmeter reading. We record what is the reading shows here. Repeat this experiment with different values of current, and then we plot a graph of voltage against current. Okay, so now you can see where is the voltage, where is the voltmeter connected at? It is connected across the dry cell. Okay, if we want to study EMF, the voltmeter must be connected to the dry cell. If you want to study potential difference across this resistor, so the voltmeter must be connected across the resistor or the electrical component here. Okay, then we see the example of result for this experiment. Ini nanti cikgu share kepada kamu video inilah. Okay, ini example of experiment. Can you hear a sound from this video?
No.
Tak ada. Later I show to you. I share to you in the Telegram group. So this is the rheostat. Okay. This is the sources of EMF. It's now adjusting the rheostat to control the current flow through the circuit. Okay. And this is the example of result he determined from it. So it shows that the current increases from 0.1 to 0.5, and this is the reading of the potential voltmeter across the dry cell. You can see that the reading is dropped. Okay, when the current is increased, the reading of the EMF of the battery decreases. Okay. So it is opposite to Ohm's law. If you remember, when you are doing experiment relating V and I, when I increases, V also increases, right? But for this one to study EMF, you can see when the current increases, the reading of the EMF decreases. Okay, as shown in this table as well. Ini contoh saja, example of result. So the current, we started from 0.2, the voltmeter across the dry cell read 2.85. And when the current increases up to 0.6, now the voltmeter reading across the battery shows 2.4 volts. So you can see current increases, V decreases. So when you plot the graph, this is how the patterns appears to be. Okay, it has a negative gradient now. Okay, opposite to Ohm's law graph. Okay, Ohm's law, remember, I increases, V also increases. But for EMF, as I increases, you can see the reading of the voltmeter is dropped. All right, so student, what is the finding we can get from this study? Okay, so from the graph plotted, state the relationship between potential difference across the cell and the current flow. So what can you say about potential difference across the cell now and the current flows through the circuit? According to this red line shows here. What can you say about the relationship? Can we say this inversely proportional?
No.
Can or not?
No.
This is not an inversely proportional graph. It only shows that when I increases, V decreases. The higher the current, the lower the voltage. Or you can say when the current increases, the voltage decreases. Okay. Okay, then question number 2, they ask you to compare these two equations. Okay, this is the equation we derived just now. Okay, the equation related voltage, EMF, and voltage drop. And I think you're familiar with this equation, right? Y equal to mx plus c. What equation is this, student? Y equal to mx plus c. What equation is this? Y equal to mx plus c. This is equation for linear graph, straight line graph, a straight line graph equation, y equal to mx plus c. Okay, so how can we relate these two equations? So actually from our graph, V ini represent y-axis. Okay, V represent y-axis. Okay, and then since I is our x-axis, so which means I is x. So negative R is our gradient. Okay, negative R is our gradient. Ni dia terbalik ni. And E is our y-intercept. So the y-intercept here shows EMF of the dry cell. Meanwhile, the gradient shows, when you calculate the gradient, it shows the internal resistance of the battery. So these are the two important things we can find from this graph of V against I for in order to determine EMF of a dry cell. The first one is the EMF. Where to get from? Y-intercept. Second is internal resistance of the battery. Where to get from? When you calculate the gradient of the graph. So how to find? Okay, this one. So the gradient represent what? Internal resistance. Okay, the gradient represent internal resistance. Arrow dia ni a few sedikit salah. I ini supposed to be represent X. Okay, and R ini represent the gradient. Okay, this one correct. Y-intercept, as I mentioned, represent or indicates the EMF of the dry cell. Remember, from this graph of EMF V against I, the gradient represent internal resistance of the battery. Meanwhile, the y-intercept represent electromotive force of the battery. So we can determine, okay, according to my graph, how to find, show. How do you show on the graph? So either you put an arrow, you show like this, or you draw a circle. This is how you show. Make sure you make any mark on it. So to show the graph, how you determine E. Okay, then only we show it is 3 volt. Okay, so one mark when you show this arrow or you make a circle on the y-intercept, and one mark when you write the correct value for the EMF. Okay, number 4, find the value of the internal resistance. Okay, how to determine gradient from this graph, student? Okay, as we do before, how to find the gradient? You can draw a triangle. Okay, a triangle. So these are the 2 points. We are using this point 0, 3. X is 0, Y is 3. And now a second point is this one. X is 0.6, Y is at 2.4. So the gradient is Y2 minus 1, 1 divide X2 minus X1. So we'll give you a gradient of 1. 1, the unit is volt per ampere. So volt per ampere represent ohm. So we know this is the value for the internal resistance of the battery. Okay, you dapat value dia negative lah. Okay, but when we write the value, it is 1 ohm, the internal resistance. Okay. Yeah, straight line graph, Cheryl. So are you clear how to find EMF and internal resistance from a graph of V against I for EMF of a dry cell? Okay, understand? Can you follow? Boleh, students. Okay, can. Very good. Okay, now our third activity for this evening to study the effect of connecting dry cell in series and parallel arrangement. Okay, so the first diagram shows to you we have batteries here, single battery. This one we have two battery arranged in parallel. Okay. So this is the apparatus required procedure. You can read, set up the procedure, set up the apparatus as shown in these two diagrams. Record the voltmeter reading. Now the switch is open, right? So you can see the voltmeter read the EMF of the dry cell. So this one 3 volt. So this one is supposed to read 3 volt. Okay, then this one also the same. Okay, we have 3 volt here. This one also 3 volt connecting in parallel. So what is the reading of the voltmeter here, students? It also read 3 volt because they are all in parallel. Okay, then fine, record the ammeter and voltmeter reading when the switch is closed. So when we close, we understand this value will be less than 3. This one also will be less than 3. So from here we can find the voltage drop or the effective internal resistance of the battery. Okay, ini example of result. We connect dry cell in series. Okay, as according to the diagram shows. And this one when the dry cell is in parallel, this one using single battery, ini using two batteries. This is the potential difference read, okay, when the circuit is closed. Okay, 2.7 for dry cell connected in series, 2.9 for dry cell connected in parallel, mean higher. Okay, and this is the current flow across the circuit. For series connection, 0.5. For dry cell connected in parallel, it reads 0.6, higher current. And this is the effective internal resistance, mean the total internal resistance in the battery. So how to find total internal resistance? So this one we can apply from this equation. Voltage drop equal to E minus V. Okay, voltage drop of the battery equal to EMF of the battery minus the V reading of the voltmeter when the switch is closed. So current, this one the current, so you can find the current here is 0.5 as shown here. Okay, the current 0.5 here. This is 3 EMF and this is the potential difference. So you can find R is 0.6 ohm. So this is the total internal resistance in the battery connected in series. While for the parallel, again we apply the same equation. The current flow 0.6. This is the EMF. This is the voltmeter reading when the switch is closed, 2.9. So by this we get the effective internal resistance, mean the total internal resistance across a dry cell connected in parallel is given 0.17, which is lower. Okay, this one higher. So which arrangement of dry cell produces smaller effective resistance? Students, from this table, which arrangement of dry cell produces smaller effective resistance, in series or in parallel? 0.6 in series, 0.17 in parallel. Which one produce smaller effective resistance? So answer very obvious there. It should be arrangement in parallel. Okay, arrangement in parallel produces smaller effective internal resistance and larger current. So we understand when the total effective resistance inside the battery decreases, so greater current will flow through the circuit. Similar to resistance, lower resistance, higher current. Okay, so this one, lower internal resistance, higher current flows through the circuit. Okay. Did you get this point for dry cell connected in series and in parallel? Boleh faham tak yang ini? Okay. So if you want to produce a brighter bulb or your bigger current in a circuit, the dry cell is better to be connected in parallel. Okay, so our bulb will be brighter because greater current will flow through the bulb. Okay. Okay, ini contoh lah. Okay, this is the last part for activity 4, effects. Activity 3, sorry, effects of dry cell connected in series. Okay, this is the example. Okay, we are using 2 dry cell, 3 volt for each. Okay, the first one connected in series. Down here, the same battery, 3 volt, 3 volt, now connected in parallel. Can you see the difference between the brightness of the bulb? Okay. Okay, can you see the difference? This one, it light up, okay, but light up statically. This one, it light up, then you can see the vibration from the lighter, mean it bright up brighter compared to the first bulb where the battery is arranged in series. So this proven to us when the battery is connected in parallel, it drives greater current in the circuit. So greater current pass through the bulb, so it bright up brighter. Okay, it light up brighter. So this is the arrangement in series. You can see the EMF and internal resistance for each. This one, 4 battery arranged in parallel. Again, the EMF and internal resistance for each. So this is the total internal resistance. So in series, we plus all. R1 plus R2 plus R3 plus R4. So give you 4R. The total for the effective internal resistance bigger. Okay. Meanwhile, for parallel, okay, this is how to determine internal resistance in the parallel connection. So it give you lower effective internal resistance. This one lower, this one higher. Okay, total EMF of the battery, this one 4E, okay, 4 epsilon. This one all the same, parallel, E. Satu saja, it read all the same. Okay, advantages. So this connection give us advantages by producing larger current throughout the circuit, producing larger current throughout the bulb. So the bulb light up brighter. Okay, dua-dua guna bateri sama, 2 battery. This one also 2 battery, but different connection give you different brightness on the bulb due to the lower total effective internal resistance, so give you larger current flow through the bulb. Okay, are you done with this? Completing this table. This one 4R, this one R divide 4, 4E, this one E. Advantages on the dry cell connected in parallel, produce larger current, okay, in the circuit. Okay. Sudah done with this?
Yes.
Okay, so kita tengoklah sedikit soalan. Okay, only a few question for tonight to test your understanding. This is the last, the 4th learning standard. Solve problem involving EMF and internal resistance. Okay, we try to do 3 questions tonight, Ken? Boleh ya? 3 questions before we end our session. Okay, number 1, student, very simple. Diagram show a cell. This is the cell with EMF and internal resistance. Okay, the EMF is 2 volt. Internal resistance is 1 ohm. Connected to a 4 ohm resistor. Okay. What is the reading of the voltmeter when it is connected across the 4 ohm resistor? So the question, what is the reading of the voltmeter here? So how to find? What equation to apply? You use the equation we derived this evening in this lesson. Okay. So what information you are given there, itu dry cell in series advantage. Apa? Tak ada. Dry in series dia tak ada advantage. Advantage is on the parallel arrangement. Okay? Okay, find this, students. So you are having EMF. EMF sini is 2 volt, so you can write E is 2 volt. Okay, this is the given information. E is 2 volt. What else given? You have R. Okay, R is 1 ohm. Okay, and here is big R. Big R here we have 4 ohm. Okay, the resistance of this resistor 4 ohm. So we are looking for V. Okay, what is the reading for E? How to find? Any idea how to find V? So how to relate this? EMF, internal resistance, resistance of the resistor, and this is the voltage of the resistor. The current is not given. Do you need to find current first in order to find V? How? Cuba fikir.
The first step is, so we need to use the formula V equals to IR to find the.
Okay.
Then use the formula E equals to V plus IR.
Okay. So can you share what is your answer here? What is the reading of the voltmeter here, students? Okay. So this is the equation. Okay, remember this equation. EMF, current, this one resistance across the resistor, this one internal resistance of the battery. Okay, so answer is this one you get 5I. 5I. Then you can find the current 0.4. So you can find the current first, as said by Sinwei. Okay, you can find the current first. Then when you find the current, now you can find V using Ohm's law equation. Okay. Cikgu punya formula ni dia punya susunan tak cantik. Okay, I rearrange back for you. Okay, this one. Where are we now? Okay, this one supposed to be turun bawah. Okay, like this. Okay. Okay. E is 2. Our EMF is 2. Okay, so this is the correct order. Okay. So now you can find I. Okay, now it is proper. Okay, like this. Okay, so we are using this equation again. Okay, use E equal I R plus R. So E is 2, the EMF. Current is not given, right? R is given 4. Internal resistance of the battery is 1. So from here, we can find the current flow in the circuit, which is 0.4 ampere. Okay, 0.4 ampere. Then we can find V by using Ohm's law equation. V equal to I R, the current flow across this resistor multiply with the resistance 4. So it gives you 1.6 volt. So you can see here, the voltage reading here is lower than the EMF of the battery, which is 2 volt. Okay, are you okay with question 1? Can you follow, understand the solution for question 1? Find current first. The idea is to find the current flow first from this equation E, I, R plus R. And then we can find the voltage reading here from Ohm's law equation. Okay, next. Number 2. Okay, try number 2, students. Okay, we have bulb M connected to a battery. Okay. A voltmeter is also connected across the battery. We place a voltmeter here. When the switch is open, voltmeter reading is 6. So what is this 6.0 volt refers to? Switch open. Switch open means this 6.0 refers to the
voltage.
EMF. Refers to the
Yes,
EMF.
EMF.
Yes, EMF. So now the quiz is closed. So the voltage here 4.8 volt. Okay, what is the EMF of the battery? Ini perlu kira ke?
Tak perlu
Tak
kira.
perlu, berapa? It's stated there.
6.
6. Okay, 6. Tak perlu kira. Yes, 6 volt. If the resistance of the bulb 8 ohm. Okay, this one bulb M, resistance 8 ohm. What is the current passing through the bulb when the switch is closed? Okay. They give you this bulb has resistance of 8 ohm. So this is capital R, 8 ohm. Find the current passing through. So what equation to apply in B, students? Okay, so you can use as we are using in the first question. You can use that apply. Okay, this one. Dia contoh apa? Find if the resistance of the bulb 8 ohm. So 8 ohm ini R. Okay, what is the current passing through M when the switch is closed? Okay, this one we can use straight away V equal to IR because what? Sini dia sudah bagi 8 volt. Okay, so the information we have for bulb M, we have its R, 8 ohm. Okay, and V is given 4.8 volt. So we can apply this to find the current 0.6 ampere. Okay, find the value of the internal resistance of the battery. Okay, how to do C, students? So now you have E from question A and B. We have
Formula.
E, EMF. We have I. Then we have V. We also have, what else we have there? So we want to find R. So how we relate this?
Yes.
Through this formula. Okay, through this formula, IR equal E minus V. Okay, so the answer will be 1.2 internal resistance of the battery divide. So divide 1.2 ini IR. Okay, so you can divide by the current 0.6, so it will give you 2 ohm. Okay, internal resistance. Or you substitute readily in this equation. I 0.6 R equal 6 minus 4.8. Macam ini pun boleh. So R is 2.0 ohm. Betul tak answer ini? Is it 2.0? Can you check? 2.0. 6 minus 4.8 is 1.2, right? So 1.2 divide 0.6 will give you, yes, 2 ohm. So this is the internal resistance of the battery. Okay, last question. Okay, last question before we end. Switch S is now in open position. Voltmeter reading 1.5. When the switch is closed, voltmeter reading drop to 1.35. Ammeter reading 0.3. Okay, find the EMF of the battery. Students, what is the EMF? Need to calculate or not? EMF.
1.5.
Where
No
to
need,
get?
no need.
No need. Why?
No
Open.
need, no need.
Okay, so switch is open.
1.5.
Open,
Yes.
so 1.5 ini shows the EMF. Yes. Okay, internal resistance. How to find internal resistance? Internal resistance is small r. Okay, how to find? What do we have here? We have E. We have, this one is V. We have I. So we can find R by the equation for the voltage drop. Again like this. Okay. So can you find the value for the internal resistance? Solve this, student. Solve this equation. So you can replace I
0.15.
0.3, R equal to 1.5 minus 1.35. So what will be the value for R? What do you get, Nicholas? So you akan dapat 0.5. Okay, yes, correct. 0.5. You will get 0.5. Okay, last question. Find the resistance, students. Find the resistance. Resistance. What is the resistance? This is the resistance. Find what is the value. So we are using
V equal to IR.
Yes, you can use V equal IR. The voltage here is 1.35. Okay, and the current 0.3. So you can find R. So R is 4.5. 4.5. Okay, how do you find EMF and IR? Problem solving. Easy or how? Can follow or not?
Yes. Yes.
Susah kan yang ini? Okay, so you can try to do the following question and I will share to you the PDF copy. Tak share lagi lah, nanti kita sambung di kelas a few more exercises on EMF. So for 5 Baiduri, we will continue tomorrow and for 5 Citrin, we will continue on Thursday, right? Are you done with your bahasa Cina ujian lisan? Done?
Yes.
How is it? Good?
5 akid done.
5 Akid done. 5 Baiduri done or not?
Yes.
5 Citrin? Not yet.
First 3 class,
Okay,
I
so
think are all done.
All done. Okay, so it's good lah. So for 5 by Dori, we continue by tomorrow. Citrin and Akid. So I see you again on Thursday. So do you have any last question before we end this lesson? Okay. Any last question? Ada siapa nak tanya soalan? So can you follow student EMF and internal resistance? Tonight can follow or not?
Boleh.
Boleh ya? Oh boleh. Okay. Any problem you can ask in the school later on. Okay. So thank you very much. I think that's all the time we have for tonight. I'm very sorry for we have excess time until 9 past 57 now, but whatever it is, I'm very, very grateful for your commitment. Thank you very much for your time. Thank you very much for your effort. Okay. So I hope this session benefits for those who are following. So I see you again next time in school. Okay. So that's all. Bye bye. And thank you everyone.
Okay. Teacher.
Yes.
Teacher.
Yes. Yeah, you can
Teacher.